and it's just going to snowball on you guys, and it's going to be the wrong time next Friday. Any of these problems that we would like to try or go over right now that you want to look at? Nothing else? Okay, everything's up on Aspen. All of my work is shown on there, so hopefully take a look at it. No, I can't force you to do it. Last call. Hello, Brianne. 7, you got it. Yep. Take a look at 7, everyone. All right, looks pretty intimidating right off the bat. For a multiple choice question, there was a lot of work involved. Just let me attach it to this page. Okay, here we go. First term was 3x y to the 5th, and it's asking for the 4th term. So I need to find the 2nd, the 3rd, then the 4th. That's why this was so much work. But it told me how to find every term. To find any term, so let's start with the 2nd term. To find the 2nd term, I take 2x over y and multiply it by the, what's this notation for from yesterday? N minus 1 is the subscript. That's the previous term. All right, so that's my previous term. So right now, where I'm at right now in this sequence, what's my previous term? I'm on the 2nd term right now. First term was 3xy to the 5th. So I need to multiply that by the previous term. Everyone good? Okay, now it's, hey, do we remember how to multiply this from last year? Numerator times numerator, denominator times denominator. So still in the denominator, you're going to have that y. 2 times 3 gives me that 6. Hey, what about the rules? Rules for multiplying. What do I do with those exponents? That's what I was thinking. Good. Nice. What do we do with the exponents? Add them up. So this will be x squared y to the 5th. Can keep going though, right? You see a y. How many y's on top? 5. How many on the bottom? 1. I can cancel them out, and I'll end up with 6x squared y to the 4th. That's just the 2nd term. I'm going to keep doing that now till I reach the 4th term. So I have the 3rd term right now, which will be, again, 2x over y. But now, what's my previous term? 6x squared y to the 4th. So I'm still left with that y on the bottom. Now what am I left with on top? Well, 2 times 6 this time, so 12. How many x's are on top now? 3, and how many y's? 4? Reduce it for me. Reduce it. 12x to the 3rd, y to the 3rd. We're almost there. Take a deep breath. We're almost there. 4th term. Same thing, 2x over y. Now, what's my previous term? Multiply it by that 12, x to the 3rd, y to the 3rd we just found. All right, let's roll. Over y. 2 times 12 gives me the 24. How many x's do I have on top? 4 x's. How many y's? 3. 3 on top, 1 on the bottom. What am I left with? 24x to the 4th, and now y squared. Magic. Questions? We are Brianne. Questions? You sure? Anybody else? This is the level we're at right now. This is the level we're at. We good? My big concern is making sure that's the previous term. Are we starting to see that now? After we do more and more of these, hey, they're asking me to plug in the previous term. Questions? More questions from the assignment. Anything else? Whew. All right, we're in for it today. Let's go. Special types of sequences. Right down there below the Algebra 2 books. Special types of sequences. All right, called arithmetic. Arithmetic. You'll see why they're called arithmetic in a second. Just to warm you guys up here, Making sure we have the recursive formula down pat. What's my first term up here? 1, A subscript 1. And then it says, all right, if you want to find any term, take the, all right, from yesterday. If n plus 1's the term I'm on, n will be the previous term. Yep, so that's the previous term. So what I need you to do in your groups right now, all right, I don't need you to, let's list out a table. It'll be term and value. So the first term was what? What was our first term of this sequence? 1. I'll help you with the second term, and you guys go on to 7 for me. What's the second term? Well, what did the rule say? Take your previous term and add 2. So the first term was 1. Take your previous term and add 2 to it. Next term? You guys all right? Next term? 3. So second term is 3. Third term, you guys go on your own, I'm done. Okay, fill it in with the rest of your group, go up to 7 terms. 7 total terms for me. It's okay, you can breathe, you can talk. Go up to 7 terms for me. Good, good, good. Okay, what was the third term? Third term in this sequence? Third term. 5. Fourth term. 7. Fifth term. 9. How about the sixth term? 11. And how about the seventh term? 13. Okay, so there's my sequence right there. If you wanted to write it out like you guys were used to yesterday, there's my sequence. Okay. Let's go to average rate. I'm going to hold off on the graphing for now. Find the average rate of change. Oh, a little review from last year. Rate of change, anybody? Rate of change, showing off. Cooper, all right, let's go. There you go. Rate of change. Is everyone all right if I abbreviate it? The ROC. Rate of change, if some of you are wondering about that. Okay, Lucas, you got that? Okay, good. What did you say, Cooper? Okay, and we're doing it from 1 to 6 now. From 1 to 6. So what were my y value? What was my y value at 6? Or the value of the sixth term? 11 minus what was my first term? 1 over, you said change in x. What am I doing this from? What values? 1 to 6, right? So on the bottom, I'm going to have minus 1. So the rate of change for this sequence will be 2. Yep, 2 over 1, 2. I got some breaking news for everybody. We have a new name for that rate of change when we deal with sequences. All right? Where did that, can anybody tell me where this 2, where else we had 2 here? Look at your sequence. What are you adding to the previous term? 2. You're going up by 2, aren't you? All right? When we deal with sequences now, this rate of change has another name, and it's called the common difference. The common difference. That's your rate of change, which was 2. In other words, in an arithmetic sequence, your common difference is what you're going by. What are you adding? Okay, what are you adding? Second thing, what the? Arithmetic. What makes a sequence arithmetic? Megan, what was I going by every term? Was I multiplying, dividing, subtracting, or adding to? Adding to. Everyone agrees? So if you see a sequence and I'm adding either a positive or a negative number to the previous term, that makes it arithmetic. So here's my challenge for you and your group right now. You come up with your own arithmetic sequence so I know that you understand this concept right now. All right? Write your own arithmetic sequence. A sequence where you are adding a positive or a negative number to the previous term to get to the next term. Go ahead. Give me about 5 numbers in that sequence right now. Talk with your group. Have a good time, man. Okay. Talk with your group. Come up with your own arithmetic sequence. And I do not want 1, 2, 3, 4, 5, 6. Let's go. Get a little creative. Give me a sequence where I'm adding the same number every single time. Okay, let's hear it. Let's start with this group right here. Ladies, go ahead. What's your sequence? Yep. So you did 1, -5, -9, -13. Okay. Why is that arithmetic? What's this group adding every single time? -4. And you can add a negative number. That's fine. You're still adding. That's what makes it arithmetic. Group in the back, what do you got for me? 14. So what would be the next term? 21. Give me one more. 28. There we go. Everyone see why that's arithmetic? You're adding what every time? What are you adding every time? 7. And now give me a name for that 7 that you're adding. Common difference. Give me a name for that -4 you ladies were adding. That's the common difference. Does everyone see that now, how this relates? All right, I won't ask another group, all right? But everyone see what makes a sequence arithmetic? And what you're adding now, we're going to call not the rate of change, but the common difference. All good. Questions? All right, let's move. Explicit formula. I'll talk about that in a second. That's going to be the equation for your sequence, the equation that represents your sequence. What I need you to do right now quickly, first term, second term, third term, fourth term, fifth term. So here's my sequence, 2, 5, 8, 11, blank. 2, 5, 8, 11, blank. Fill it in for me real quick. 2, 5, 8, 11. Next one, Annika. 14. How'd you know that? Okay, adding 3 makes this sequence what? Arithmetic, perfect. And you said you were? Adding 3. Give me a name for the number 3 in this case. Common difference. So the common difference, and let's, I should have did this before in the last slide, but common difference is the symbol for common difference. Lowercase d. Lowercase d. Now here's what I want right now. I'm going to help you write an equation that represents this sequence. All right, I'm going to help you write an equation that represents this sequence. And this equation now we're going to start referring to as an explicit formula. That's what an explicit formula is. It's an equation that represents your sequence. Here's what the general form is going to look like. A subscript n, oh, all right, we've seen that, equals A subscript 1, meaning first term, good, plus n minus 1 in parentheses times lowercase d, we just found out represents, that's my common difference. Okay, that's my common difference. So here we go. Here's how we're going to use this formula. We're going to keep n as n. You told me A subscript 1 meant what, Isabella? Well, A subscript 1. Not n minus 1, not plus 1, just A1. Like A2. What's A2? Second term, right? So what's A1? What's the first term in my sequence up here? 2. 2 plus. Lucas, did we plug anything in for n here? Nope. So guess what we're not going to do here? We're not going to plug in for n. Brooke, what was my common difference here? 3. I went by 3s. Can you guys clean that up for me? Clean that up. Distribute the 3 and combine like terms. Distribute the 3. I end up with 3n minus 3. Combine like terms for me. Tell me what the explicit formula, the equation of this sequence will be. 3n minus 1. Now let me describe to you how powerful that sequence, this formula is for you. Do you remember the problem we did yesterday, where some of you were probably cursing me under your breath because I asked you to find the 20th term? And remember all the calculators that came out were like plus 5, plus 5, plus 5, plus 5, plus 5. So you got to 20. Everyone remember that one? It was such a pain in the butt. I don't have to do that anymore. If I want to find the 20th term of this sequence, the 20th term, you do not have to go to your calculator anymore. Plus 3, plus 3, plus 3, plus 3. Here's what you can do. If I'm asking for the 20th term, guess what I'm going to plug in for n? 20. Yes, I'm going to plug in 20. So I'll do 3 times 20 quickly. Anybody? 60 minus 1. So the 20th term is going to be 59. I don't have to don't have to do that anymore. Okay? That's the power of this. Hey, if I wanted to find the 100th term, guess what I would plug in? 100. Okay? If you don't believe me, ready? Let's find the second term, even though you already know it's 5. Plug in the number 2 right now. 3 times 2? Minus 1. Ding, ding, ding. That was the second term, wasn't it? Okay? That's the power of using the explicit formula. Whatever term you want to find, you can plug that term in, all right, the number of the term you want to find, and it'll give you what the term will be. We see that? We good? Now, here is more good news for you. You thought I was going to have to, you guys are going to have to memorize that, huh? So you could use this? Nope. Got some good news for you. Do you guys remember in algebra and geometry, you guys always got a formula sheet? That formula is on this formula sheet, which means the following. Any test or quiz we have, you'll have this formula sheet with you. Okay? So take it right now. We'll hole punch it at the end of class and locate this formula right now on the formula sheet. Does everyone see the tab? It says Arithmetic Sequence. And everyone see the explicit formula for it? Everyone see? We're good, so we know where it's located. There's other types of sequences on there, which we'll deal with next week. But for now, we're just focused on the arithmetic part. Okay? All right, let's use it now. Let's use it. All right, you already have seen that. You have it on your formula sheet now. Let's use it. And this is where the fun's going to start. All right, for number 1, find the indicated term using the following information. All right, well, what information am I given? I'm given the first term, and I'm given the what value again? Common difference. So everyone stop. I know it's arithmetic sequence day, but next Wednesday, you're going to have a couple other sequences to deal with. What in that problem tells me this is going to be an arithmetic sequence? What signifies right away, oh, I'm dealing with an arithmetic sequence? Common difference is given. The D value is given. And the D value is only given if it's an arithmetic sequence. Everybody good? All right, so I take my explicit formula I've been working with, coming right off your reference sheet. And now I'm going to plug in for as many values as I can and watch the magic happen. Where's the 10 going? Matt, where's the 10 going? Yep. What's our n value here? Reagan, what's my n value? It's 9. So everywhere you see an n, I'm going to plug in 9. So ready? I'm fine. Actually, what am I asking you to do? Find which term? 9th term, yeah. Plus, what did I just plug in for n? 9. So whatever I plugged in for n here, I'm going to plug in here. 9 minus 1. And my common difference was times -5. Make sure it's not -5, times -5. Can you guys handle that? Go ahead. Let me know what you end up getting. What is the 9th term? And we end up with the 9th term being -30. Yep. Using my new formula. Any questions, comments, concerns yet? You all right back there? Great. What happened? Just rolling solo today, huh? Okay. Patrick, field trip? Just say it. You don't know though, but just say it. Okay. Okay. You don't have to act all awkward about it. It's all right. We can communicate. It's okay, Annika. All right. All right, here we go. Number 2. Write the equation. Okay. Write the equation for the nth term. That means give me the explicit formula. Give me the equation for this sequence, like we did on the previous page. Okay, anytime you're asked to write the equation for the nth term, write the equation of the sequence using your formula. -8, -6, -4. So get out your formula. You are not going to plug in for n because we're trying to write the equation for the nth term. So that's just going to stay a subscript n, everybody. All right, let's roll. Catherine, what's the first term? -8. So -8 plus, not plugging in for n, -1. How about that common difference now? That common difference. What's up, stud? Look at you. Yes, +2. I'm adding 2. So multiply by 2. Clean it up now. Clean it up. Distribute, combine. What do we got? 2n minus 10. So there's the formula for that sequence. Now, Ethan, ready? Let's say if I had a part B to this question, it said, find the 80th term. And I am not expecting you to go on your calculator. How could I use this formula to find the 80th term? Plug 80 in for n. Okay? That's how you use the explicit formula. Anything you want to ask? Pretty neat, Matt, huh? Good. Anybody else comment on your fresh cut? Okay. So I try to notice. I try to notice. Hi, Megan. Just party crasher here. But go ahead, Megan. Go ahead. Correct. This formula is specific for adding the same number every time, or adding the negative number. So it's adding, but you could also think of it as subtracting too. Like if I was subtracting 3, yes, you could still use this formula. Okay. Multiplying, that's next week. That's a whole different story. All right, here we go. Find the 20th term. So go ahead, use your new formula in your group right now. Find the 20th term of this arithmetic sequence. So take your explicit formula off the reference sheet, plug in all the values you can to find the 20th term. I do not want to see people just adding 7, adding 7, adding 7. All right, use the formula to get there. It's so much quicker. I think you can handle it. You guys seem pretty strong so far this year. Let's do it. Find the 99th term. I'll let you do that one on your own. Go ahead. Find the 99th term of that sequence. Whoa, hold on. It didn't say it was arithmetic, but how do you know it is? Without the problem saying it's an arithmetic sequence. Are you adding the same number every time? Yes, you are. That makes it arithmetic. So go right ahead. Find the 99th term for me. And some of you might say, oh, that's so ridiculous, 99. You know why I asked you to find the 99th? So you don't have to go plus, 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 plus 99 times. Nobody's going to do that unless you're in desperation mode. Sorry if I just offended somebody. Okay, 384. 384, last of the basics. Anything? Questions? Okay, let's finish strong now. Let's finish strong with a couple of these advanced ones now. Write an equation for the nth term, all right? So once I see those directions, write the equation for the nth term. I know they're telling me explicit formula. And I'm leaving n just n. Okay, write the equation for the nth term. So use your explicit formula. And leave n the way it is. But we run into a huge problem here. Not only, I don't know all the values I need to plug in. I know I'm going to leave n the same, so that's not a big deal. I know the d value is negative 11, but they don't give me the, right? They don't give me what? The first. They actually give me the sixth term. And I need the first term to plug it in to write the equation. So is there anything you can think of that'll help me out? I know the sixth term is 11. I'm subtracting 11 every time to get to the next term. Can I use both these together to get to the first term, which I need? Can we do that? Well, let's see. I always like to look this out visually. Ready? 1, term 2, 3, 4, 5, 6. So the sixth term is 11. What did I do to this term to get to 11? I subtracted 11, right? So what do you think I have to do to go backwards? Add 11. So what was the term before 11 then? 22, right? Because it says subtract 11 to get to the next term. So to go in reverse, why don't I add 11? So what do you think the third or the fourth term was? 33. Can we keep going and find the first term for me? Go right ahead. Go right ahead. And your first term ends up being 66. Yep. So now I can go back to my equation now that I know it's 66 and say, all right, to find any term, I take 66 plus n minus 1 times the d value of negative 11. And then you guys know distribute and clean up for me. Distribute and clean up. Negative 11n plus 77. Okay. Just a quick question, make sure we're all on the same page here. Emma, ready? If I said, Emma, what's the 100th term of this sequence? What would you do with that number 100? There you go. Plug it in for n, figure it out, and there's your 100th term. Okay? Are we okay there? Little change up, right? Because I wasn't given the first term. All right, let's see what we're not given this in number 6. Find the first term of this arithmetic sequence. I give you the 5th term, and I give you the d value. All right, well, I know it's arithmetic, and this is the only equation I have to work with, this explicit formula. I'm going to take my time here. I'm trying to go A1 here. This is what we're going to leave blank because I need to solve for it. You can plug in for D, right? That was given as 4.5, but I have to plug in for the rest. I need to plug in for the rest. Okay, it's going to be A sub 1 plus, I'm going to put something in that parenthesis, set it equal to something. How can I use this value here to help me out? Well, what term is this, guys? 1.5 is the 5th term, right? So what number could I plug in for n then? What's the subscript? What's the subscript? What number could I plug in for n? I can plug in, since I'm given the 5th term, I can plug in 5 for n. Now be careful here. I'm not going to plug 5 over here because this is what? This would be the 5th term I plug in. What is the 5th term? 1.5. Take a look. The 5th term is 1.5. All right, let me go back and review all that again. I needed an n value. Well, I was given the 5th term. That subscript is 5. So that means the subscript for n here is 5. So I plugged in 5. And I said, all right, the 5th term then was 1.5. So it went on the left side of the equal sign. Ask anything here. We okay on that part? I just don't want to plug it in, copy down, and we're good here. Because you're going to be in this predicament on your own here soon enough. Can you solve that now on your own? Okay. 1.5. Plus 4 times 4.5, 18. What do you want to do with that 18? Remember, this is just a subscript 1. That's just a variable, like x, like y. How do you want to move it over? Subtract it. Subtract it. Go ahead. And first term was? First term? Now, you don't have to do it this way. Was anybody thinking another way before I started pulling out the explicit formula? You knew the 5th term was 1, 2, 3, 4, 5. You knew the 5th term was 1.5, and you're going by 4.5. So what could I do to go backwards? Subtract 4.5. Okay, so that's fine. Hey, I don't care. Whatever gets the job done. If you use the formula, great. If you don't, you want to just write it out by hand like this, fine. Whatever gets the job done for me. All right, everyone, any issues? Guys are going strong. Oh boy, reading. Pack it in now. Oh, Trev, how you been? Has opened up an English language school in Japan. Good for him. Humanitarian of the year, Trev. Well, he began with 26 students. And every week he gets 3 new ones. How many weeks will he have? 101. Well, why is it arithmetic? Of 3 new students every week, right? So he increases it by 3 every week. And guys, I do not want you to go 26, 29, 32 and see how many times it takes to get to 101. I'm trying to have you guys use your explicit formula as much as possible. Okay, so what can I plug in for? Anything you want to plug in right now. Tell me a number and where to plug it in for. Megan, 26 in for A sub 1. Plus any other numbers I can plug in right now. There's others. Catherine, 3 for D. Nice job. And I still got that 101. It's in for A sub n. Yes, hey, look, I'm going from 26 all the way to 101. And I want to know how long is that going to take me? Okay. So go right ahead. How many weeks is Trev going to have to open up his English language school to get 101? Hopefully you're getting full weeks and not 0.2987 of a week. How many weeks is he going to open it up for? Oof, 26 weeks. What is that, about 6.5 months? All right. Good luck to you. Is there anything? All right. We got one more, right? Nope, we don't. Sorry. Damn. Thought we had it. Okay. Here are the first 3. Look at these checkered patterns. Beautiful. First 3 terms of the sequence are represented. Write an equation for the nth term. Okay, write an equation for the nth term so you guys know you're going to get your explicit formula out. And it's for the gray squares we're doing. All right, for the gray squares, the shaded ones. Okay, A sub 1, go ahead, count them up. A sub 1, how many shaded squares do I have? Do I? Is that confirmed by anybody else? 12? What? I've already did. Step up on you. N minus 1, now you got to tell me how many more shaded squares each time. Yes, I do have 12 here. Let's see, I have 12 shaded squares here. How many are here now? And then let me guess how many are at the end. 20? So what are you going by? 4s? Go ahead and clean it up. Clean it up. Four n plus 8. So I think you guys have had a lot of practice here. Whoa, whoa, whoa. That's what I thought. Yep, get it back open. We go right to the end here. All right, let's do this. Lucas, you ready? Because I'm going to ask you a couple questions here. Flip your page so you can start. Cripe. All right. Arithmetic means terms between any 2 non-consecutive terms of an arithmetic sequence. Good. So here we go. I want to find 3 arithmetic means between 2 and 22. Here's what that means. This is an arithmetic sequence. You got 2 and 22. Find me 3 terms in between that make it arithmetic. This is an arithmetic sequence. Big challenge here. It's an arithmetic sequence. I start with 2, end in 22. What must be the 3 numbers in between that make it arithmetic? Meaning I add the same number every time, and I'm going to end up at 22. What value would it be awesome to know? I got to figure out what I'm adding, right? So what value would it be great to know, Annika? The common difference, right? Then I could add it and easily find those 3 terms. So get out your formula that's got common difference in it. Not going to stop me. Not going to stop me. What's the first term? 2 plus, ready? How many terms do I have? How many terms do I have? No. Total terms here in this sequence. 5, so that's my n value. 5 terms. You're solving for D, right? What's the end number of this sequence? 22. And now you can solve for D, and add it to 2, add it to the next one, add it to the next one, and it'll end up at 22. Thank you for staying with me here, guys. Appreciate it. Please try some of this stuff out. Almost begging at this point. Try some of it out.